Hey guys, welcome to 13.2 where we're going to talk about how to name acids and bases. First thing before we get started is I want to talk about two pieces of vocabulary that you should know prior to naming them, and that's a binary acid and a ternary acid. Binary acid, based on its name, is an acid that has to do with the number 2. Okay, and that 2 is referring to how many elements are present in the acid. Okay, so it means 2 elements. For example, here are some examples of binary acids. HBr, it has Br and it has H. Another example would be H2S. Again, it has S and it has H, so it only has 2 elements. Okay, this little number here does not matter. That doesn't count as 3 elements total because just because we have 2 H's, we still have 1 element H and then 1 element S. A ternary acid is anything that has 3 elements. So for example, H3PO4, here I have 3 elements, H, P, and O. Another ternary acid would be H2SO4. So H, S, and O are 3 elements, so it's ternary acid. So we're going to talk about how to name binary acids and ternary acids. Okay, here's my basic rule. This is my little table that talks about the rules. If you have a binary acid, so if you have H and something else, H and specifically that something else will always be a nonmetal. Okay, so H and a nonmetal, the way you name it is you put before you write anything else, you write hydro, and then you put the name of the element right here, which is just the name of the element on the periodic table, and then you add ic acid. Okay, so for example, this guy right here, it's binary, and so I would name this hydro, and then I put the name, so this would be sulfur, and then I add my ic to the end, and then I write acid. So this is hydrosulfuric acid. Okay, if we have a ternary acid, there's 2 types. There's a ternary acid where H is with a polyatomic that ends in 8, like this one. This is sulfate. Okay, so it's H with a polyatomic that ends in 8. Or you can have H with a polyatomic that ends in ite. So this would be an example of one, H2SO3. That's called sulfite. Okay, so if you have an H with a polyatomic and the polyatomic ends in 8, then you're going to write the name of the polyatomic here, and then you add ic acid. There's no hydro in front. If you have a polyatomic that ends in ite, you put the poly's name here, and then you just name it. You put the ending OUS acid at the end. Again, there's no hydro. So hydro is only for a binary acid. So let's practice. First, I want you to mark down whether these are binary or ternary. Okay, and I'm going to do, I think I'll do maybe 2 with you, and then I'll let you do the others. Maybe I'll do 3. So this one here is binary because there's 2 elements, so I'm going to write bi. Here, there's no polyatomic, so I'm going to put an X through it. If it's binary, just put an X in this next box. And then lastly, we're going to name it. So binary ones, remember you put hydro, then you put the name of the element, which is bromide. But I'm going to just put, if it has ide, just take the ide part off. So I'm going to put BROM, brome. And then you put the ending, which is ic acid. So this is hydrobromic acid. Let's do another one. This one is a ternary acid, okay, because it's got 3 elements. And then we have to write down what's the polyatomic ending. Well, NO2 on my polyatomic chart, if I look right here, NO2 is nitrite. So it ends in ite. Remember, anything that ends, a polyatomic that ends in ite has an OUS ending. So I'm going to write and instead of adding nitrite, I'm going to put nitrous, this is my new ending, acid. Notice I did not put hydro because it's not binary. Okay, let me do one more. Let's do this one right here. It's ternary because it's got 3 elements. PO4 is phosphate, which ends in 8. And so any polyatomic that ends in 8, we're going to change it to, instead of phosphate, we're going to take it to phosphoric. Okay, instead of OUS, we're going to do phosphoric, and then you put acid. Okay. All right. So let's look at the names down here. These names are, I'm given names and I have to write the formula. So let's do this first one together. This one, it doesn't have hydro, which means it's a ternary. Okay. This has the ending OUS, which means the polyatomic ends in ite. So this polyatomic, if it's a polyatomic and it ends in ite, it's going to be PO3. Okay, and it's an acid, which means it has to be with H. So now I just have to even out charges. PO3's charge is a -3. H's charge is a +1. So to even them out, I need 3 H's. So H3PO3 is my formula. Okay, let me do another one. This one has a hydro in front of it, which means it's a binary acid, which just means it's this element plus H, okay, because acid stands for H. So it's H, which is a +1 charge, and then IODIC stands for iodine. So I'm going to put iodine here, and iodine is in group 17, so its charge is -1. So since those charges even out, it's just HI. So it looks like it says high, which is kind of funny. And I'll let you do the others on your own, okay? Now let's go down to bases. Bases are actually easier than acids because it's just like naming an ionic compound. Basically, you name the metal, and then you say hydroxide at the end, okay? So this one is going to be named magnesium, and then I'll put hydroxide at the end. If I give you the name and I ask you to go backwards, you just have to make sure you even out charges. So strontium is Sr and OH is, or hydroxide, I'm sorry, is OH. Hydroxide's charge is -1, and I know that because I look on the polyatomic chart. And strontium, it's in group 2 on the periodic table, so its charge is +2, which means to even them out, I need 2 OHs. So SrOH2 is my formula for strontium hydride. So I want you to write the formula for potassium hydroxide and then write the name for BaOH2. Now that we know how to name them, we can actually predict and write equations for neutralization reactions. So I'm going to do 2 of them with you. Okay, this one I've been given the formulas, which is great. H2CO3 is going to react with SrOH2. Now remember, a neutralization reaction can only occur if your acid and your base are both Arrhenius acid and bases. Okay, Arrhenius means that the acid has an H and the base has an OH. And so I always create 2 products. What are always my 2 products in a neutralization reaction? It should be water and a salt. So water is one of my products, okay? Basically this and this combine together to form water. What is left over? Carbonate is left over and strontium is left over. When you're writing a salt, always list the metal first. So my metal is first, and the non-metal or the polyatomic is going to be after. So here's my polyatomic, CO3. Now before I can move on, I've got to even out charges, right? Strontium's charge, because it's in group 2, is +2. And carbonate's charge, I look on the polyatomic chart, its charge is -2. So those charges automatically even out. So I don't need to add any more strontiums or carbonates. So that is my formula. And then lastly, before I can move on, I just need to make sure it's balanced. So I'm going to erase this here and try to balance out my atoms. Okay, so I'm going to put my lines here and I'm going to balance out my atoms. Here I have, remember, since I have carbonate on both sides, I'm going to leave it together. I have 1 carbonate on the left and 1 carbonate on the right, so that's good. My carbonates are balanced. I have 1 strontium on the right and 1 strontium on the left, so that's balanced. Here I have 2 H's plus 2 H's, so I have 4 H's on the left, but I only have 2 on the right. So I put a 2 here, my H's are balanced. I have 4. And now I have 2 oxygens on the right, and I have 2 oxygens on the left, so I'm balanced with my oxygens as well. Okay, now let me do one of the word ones for you. This one's a little bit harder. Let's do C. C is a little bit harder because I actually have to write out the formulas for these 2. Then I can predict the products. So what's my formula for hydrobromic acid? Well, hydro means it's a binary acid, right? So it means it's just H plus the nonmetal bromide. Right? I just have to even out charges. H is a +1 because it's in group 1, and bromine's a -1 because it's in group 17. So they automatically even out. I'm going to add it to barium hydroxide. Barium's charge is +2 because it's in group 2. And OH, if I look on here, has a charge of -1. Barium's +2, hydroxide's -1. I have to add a second hydroxide to get an even charge. So I put a 2 here. Now what's that going to form? Now remember, since it's neutralization, H and OH will always form water. So here's my water, okay? But I'm also going to form a salt. So if H and OH are used to form water, what's left over? Bromine is left over and barium's left over. Remember, the metal is always written first. So barium is my metal. I put that first. Br is my nonmetal. I put that second. And I have to even out charges. So barium's charge, like we said before, is +2. And like we said before, bromine's is -1. So in order to have a neutral compound, I need a second bromine to even out those charges. Last but not least, I need to even out my atoms on both sides. So I see that on this left side, I have 1 bromine. And on the right side, I have 2 bromines. So I really need 2 bromines over here, right? So that they can even out. What about my H's? On the left, I have 2 H's here, but 2 H's here. So I really have 4. On the right, I need 4. So I'm going to put a big 2 coefficient there. I also have 2 oxygens here, and I have 2 oxygens here, so that's good. I have 1 barium and then 1 barium. So the rest of it's balanced. These are just 1s. All right, so you have a couple on your own problems to do to get credit for this video, and that's it. You're done with 13-point dose.